If you argue that big data requires all of the three V's, volume, velocity, and variety, at once to count as big data proper, then is it possible to be a data scientist if a person with domain expertise and statistical knowledge and encoding skills without touching big data? We'll look at a few of these possibilities. First, let's review our Venn diagram of data science. This again shows on the top right we have statistics, on the bottom we have domain knowledge, and on the top we have coding. Taken together, those class to data science. We also have a Venn diagram for big data, where we have volume and velocity and variety, and again, depending on who you ask, you need to have all three of them at once to have big data. So let's take a look at data science for just one V at a time. So we're talking about statistics and domain knowledge and encoding, but with just velocity or variety or volume. The first example we want to look at is volume of data without any remarkable velocity or variety. So, this would mean a very large and static data set with a consistent format. The data would generally be structured as well, so we're not gonna have free text. A good example of this is genetics data, as I'm showing right here from Nature Reviews. Genetics data is huge. It's enormous, but it follows a well-understood structure, and now there's an enormous amount that you have to do to work through it, but it's consistent in that way. Next is data science for velocity without volume or variety. So, this is referring primarily to streaming data with a consistent structure. By streaming data, we mean that data is coming in consistently, and very often you're not holding on to the data. You're just keeping a small window of it open. One interesting example is the earthquake detection systems of the United States Geological Survey. This is the Advanced National Seismic System, which is simply looking to see whether there are earthquakes that are happening or really about to happen. And you don't necessarily need to hold on to all the data if what you're trying to do is trigger a response so that if an earthquake is imminent, or if it's just starting, people may have enough time to respond to it. Another term for this kind of data where it's coming in very fast, but you're not necessarily keeping it, so it's relatively low in volume, and it may have a very consistent structure, so it's low on variety. This can also be called data stream mining. And one possible example is what's called real-time classification of string and sensor data. Finally, for one V at a time, let's talk about data science for a data that has variety. So a lot of different formats without velocity or volume. This is where you have a complex, but small or static, or relatively static data set. A couple of examples could include facial recognition and personal photo collection, so you don't have an enormous number of photos, but you do have a lot of variety. Visual data is almost always very high in variety, and it may be static because you don't add to it constantly. Or you can talk about the data visualization of complex data sets. Now these are examples of data science, which again means statistics, and it can mean domain expertise, and it can mean coding, or you're doing just one of the V's of data at a time. You can also do two V's at a time. So for instance, you may talk about data science for data where you have volume and velocity, but not a lot of variety. So for instance, a lot of data is coming in very fast, but it's in the same format. You can include, for instance, stock market data. Here is another example. It has to do with jet engines. And a surprising statistic here comes from this chart. It is estimated that a jet engine has sensors on it that generate 20 terabytes of information each hour. That's an enormous amount of information. For instance, 20 terabytes per engine per hour times 2 engines, times 6 hours cross-country flight, times 28,000 flights, and 365 days a year. The total data generated is over 2.5 billion terabytes of data per year just from jet engines alone. The point here is, it's a lot of data, and you would want to hold on to that because the failure of a jet engine is an extraordinarily important thing, and so you want to be able to find the patterns in it fully. Another possibility is data science applied to data that has velocity. So it's coming in fast, and there's a lot of variety, but not a lot of volume. So again, this is streaming data where you're not necessarily holding on to everything. One interesting example of this is surveillance video. If you're saving all the data, then that's an enormous volume. On the other hand, if you're not saving it but you're streaming it in, it's very fast because the information comes in very quickly. Maybe 20, 30 frames per second, and it has a lot of variety because it's visual information. But if you're simply wanting to see, does a person come through, for instance, who's carrying a weapon, or does a particular event occur? You use a stream and you're just trying to trigger when something happens. Finally, let's talk about data science for volume and variety without velocity, and this can be any large historical data set that uses multiple formats or includes visual data. A really good example of this is Google Books. We've looked at this before, where they have 30 million books that they've scanned and they've digitized them, and you're dealing with a really complex information here. Similar examples include the Twitter archives, where every single tweet that's ever been written has been saved. That's an enormous amount of information because its text is complex, but because it's not updated constantly, it doesn't have the velocity. What these examples show is that despite the strong association between big data and data science, the skills of data science, the statistical knowledge and domain expertise or knowledge encoding skills, those apply even when the three major aspects of big data aren't all present at the same time. In the next presentation, we'll look at the flip side of all this: how to work with big data without requiring the full data science skill set.